So on these first three problems, today's just a review day. We had a ton of stuff yesterday. I'm also going to dip back into things before yesterday and review those with you too. But the whole point of domain is, what can you safely feed this function? Can you just feed this anything? No, because when you put in some negative numbers, this thing will turn negative, and then not every negative number? No, actually, you could put in -1 and this thing would be fine, because the square root of 0 is okay. All right, so -1 is safe to feed this function, but how about -2? No, that wouldn't work. So basically, you're trying to figure out what is safe to feed this, and you don't want square roots of negatives. All right, so you should have said that 3x plus 3 needs to stay greater or equal to 0. And then that'll be 3x greater or equal to -3. And x greater or equal to -1. Raise your hand if you had that one right. Okay, cool. Any questions? All right, then on to the next one. This represents my favorite saying. If you can factor it, you should. You should have just said x plus 2 and x minus 2, because then why? I can now see what makes the bottom 0. Really easy. What would make the bottom 0 is if x was -2 or if x was 2. So here's a really easy to make mistake. If all you said was x cannot be 2 and x cannot be -2, you done messed up, because this is a list of the things it can't be. What you're trying to do is give a list of things it can be. So everybody, if you haven't already, make this into a number line and tell me what is safe to feed this function. Stella, describe a number line that would be graphing the things that are safe to feed this function.
You would put zeros, or like not zeros, the empty circles.
Yep.
For 2 and -2.
Yep.
But then everything else is covered.
Yes, you shade in everything else, basically saying everything works except -2 or 2. Excellent. And then last but not least is this one. I get there's some agonizing over, like, okay, well, what am I supposed to do? Am I supposed to set it greater or equal to 0? Am I supposed to, like, not let it be 0? And hopefully you realize what's safe to feed this function is anything. The answer is all reals. Why? Because tell me a way that you could crash this. Can you make it have a square root of a negative? No, there isn't even any square roots. Could you make it have a denominator that was 0? No, there isn't even any denominators. I mean, if there was a denominator, it's a 1. And so therefore, we don't need to worry about the denominator or square roots. So this is all reals. I'd say -infinity to +infinity. In this case, that's easier than drawing a number line. Usually number lines are easier, but this time, what format is that again? It's an answer in what notation? Interval. Okay, questions? Yes?
So if I just wrote all real numbers, that would be a different...
Actually, I would have accepted the words all real numbers. That would have been okay. All right. Next, I want to see how careful you are. Remember how I told you that this is the careful test? I'm going to have you stick x plus h into a function and then subtract the function. Well, what do you need to be able to do that? The function. So here's the function. F of x is 3x squared minus x. There are so many negatives and things that are weird that come out of this, but at the end, when you're all done, you should have an answer that has h in it, and your answer might be like 2xh minus 3h. It's just a few terms left because most things cancel, all right? So if you're stuck on even how to start, you take this function right here and you write it as 3 empty spot squared minus empty spot. And then you stick in x plus h first. And then after it, you're going to subtract the function. It's another place to mess up. So that's the bare bones how to start it. I'm going to pause for a minute while everybody tries this. Not easy stuff, I know. So I'm going to get this one started and see if you made a mistake yet. There should be an x plus h here. And then there should be an x plus h here. And then you should subtract the function, but it needs to be in parentheses. If you forgot to put this 3x squared minus x in a parentheses, this isn't just like, oh, you're just being picky. No, you wouldn't have distributed the negative to both of them if you hadn't remembered the parentheses. Okay? So if yours looks like this, you were off to a good start, but you still have many places where you could mess up. Right here, you might just think it's x squared plus h squared, but it's not. And it would make your life a lot better if you can jump right to x squared and h squared, but what's in the middle? Plus 2hx. If you can learn to do that in your head, that'd be awesome. If you need the crutch, though, write x plus h and another x plus h, and that'll help you remember to do the FOIL thing, the first outside ones, the inside ones, and the last ones. Now I'm going to do my 3 in front of that. And then I have minus this xh. Where'd that come from? Because you put in x plus h in both of the x's. This x gets an x plus h, and this x gets an x plus h. That's where this x plus h came from. Now I'm going to distribute that negative, negative x, negative h. And then I'm going to distribute this negative, negative 3x squared. And a negative negative x makes plus x. Now distributing out my 3. 3x squared plus 3 times 2 is 6xh, or hx, it doesn't matter. Plus 3h squared minus x minus h minus 3x squared plus x. Holy cow, so much busy work. 3x squared, negative 3x squared. Look for things to cancel. If you're doing this kind of problem right, stuff cancels. Plus x minus x. Awesome. Is there anything else that will cancel? Nope. So it's 3h squared. I'm putting that first, but you don't have to. Plus 6hx minus h. Who was able to hang in there and get it perfectly right? No little oopses. All right, that's less than half the class. So you're normal if you messed this one up. Is there any part of it that you want me to re-explain, like, how did you get that? Yes?
Yeah, how did you get the first line that you wrote, the 3 and then...
Right here?
Yeah.
All right, so see what I just underlined really dark with green? That's the same thing as this, the original function, except I put in an x plus h right here and right here. See, they went in right here and right here, where the x's were. I put in x plus h's. Do you get how that's this same exact line? 3 x squared minus x, except inside where the x was, I put x plus h.
But then what happened to the first minus f of x?
Okay, the first f of x. Do you mean this f of x here?
Yeah.
That's this. I'll highlight them in red. This f of x, that's this. Okay, so if you think of this in stages, this part here, f of x plus h, that's where you're sticking x plus h in the function. So that was the blue part right here. This was where I stuck in x plus h in the function. And then the pink part, that was where you subtracted the function. All right. If we have time at the end and you want another one like this, I'm going to call this the careful problem. You can always ask me to do another one of those careful problems. Okay? But I want to get through the rest of the stuff that we've talked about. So yesterday I gave you an example of, give me a function that, everybody make me a function that does these 3 things in this order. First, I want you to make the function add 3 to the number. Make me a function that adds 3. Well, that's easy. Everybody can make a function and have it add 3 to a number. So you'd say like x plus 3. But then, in this order, I want it to multiply by 5, and it'd be really easy to buy x and make it so that multiply by 5 would be first. You don't want that. You want it to add 3 first, then multiply by 5. And then 3, I want you to have it divide by 7 last. Make me a function that adds 3, multiplies by 5, and divides by 7. In that order. Elizabeth, what do you say?
Oh, it would be x plus 3 parentheses times 5.
And that 5 could be at the beginning or the end, and that's good so far. That will make sure that the add 3 happens first. Okay, now what?
Over 7.
I like that. All over 7. That would ensure that you'd want to get the whole first part, the top part done of the fraction. Okay, why would that have to happen? Technically, if you make a giant fraction, you're implying parentheses around the whole top. Those are implied parentheses. A lot of people don't know they exist, but they do. So that one would multiply by 5 and then later divide by 7. Could you just say divide 7 this way? Sure, that would have been fine also. Any other questions? All right. Now, use your function and tell me what is the answer when you put in C. I want you to find f of C. Got to get used to putting weird things in your functions in pre-calc. It's not that complicated. You just put in a C, but you do need to simplify it down after that. So I'm going to put a C right here, and I'll have C plus 3 in parentheses times 5 all over 7. So then I'm going to distribute that out and say 5C plus 15 all over 7. On the test, we'd be clear about how far you had to simplify it down. It'll probably just say simplify, and that would be simplified enough. Now, on our test, I could absolutely see that being a 5, so that then you'd have to like factor, you know, if you can factor it, you should, and then a 5 would cancel if that 7 was a 5. Okay. All right. That's enough on that. Now, what else did I teach you yesterday? Can you name a topic besides make a function that I taught you yesterday?
Like split graphs?
Split graphs, yes, those are called piecewise functions. Let's do one of those. It's going to be x minus 4 when x is less than negative 1. It's going to be x squared when x is between negative 1 and 2. And then it's going to be absolute value of x when x is, there's only one place left. Can you do it? We've got the numbers less than negative 1 all covered. We got the numbers between negative 1 and 2 all covered. So it has to be greater than 2. Very good. You can use logic to know I was going to say all the numbers bigger than 2. Now, a way I'd start, I'd make a graph. Then I'd put my divider lines. This is not the right place for them. But let's say I thought that I was going to have 3 parts to my graph. The left, the middle, and the right part. I did not put in my divider lines in the right spot, but you put them in the right spot. And then remember, when you graph this, if you're like, I can't think of any numbers that, like, I don't know how to graph this, then make an XY chart. It's your best friend in graphing. You can make an XY chart and pick numbers that are between negative 1 and 2. And then you can make an XY chart for this one and only pick numbers that are less the -1 and put it in this function, and then you'll get your little XY chart. You can always make an XY chart for all three of the functions. But again, don't be dumb and just pick any number you want. Pick numbers that are greater than 2 for your last one there. So make an XY chart if you get stuck. Otherwise, if you can hand graph it, you go, oh, I know what that is. It's a parabola. I know what that looks like. I'm okay with that, as long as you have some accurate points on it. Pausing. Okay. The divider lines weren't where I put them, but where are they actually? I'd look at these. -1 was a key spot. I'm going to put a little dotted line where -1 is. Now, don't think that that's an asymptote line. It's not. The function can exist there. I'm just trying to, like, divide up my graph into its three parts. So this is where x is -1. And then it goes to 2. Well, and that'd be about here-ish. There's x equals 2. And now I've got to find some points that are at x minus 4. That's this part of the graph here, this whole part right here. Okay, I'm going to highlight it in right there. This part of the graph. And that is, I'm going to start at -4, which would be down here. And then I'm going to have a slope of 1, and I think it would look something like that. That's kind of my ballpark of what it would be. But if I want to get some actual points, I'm going to put in like -1 itself. But wait, you say, you're saying it's supposed to be less than -1. Well, I'll just put an empty circle there. I'll put in -1, and I get -5. -1, -5 would be like there-ish. Cool, I got the idea. Now I'm going to put in another one like -2. And I get -2 minus 4 is -6. -2, -6. And that's going down at a nice pace from there. And that's a filled in one. And there. That's the first part of my graph. Raise your hand if you had that one right. Cool. Then the middle part. I put in numbers that are between -1 and 2. And I can actually use -1 and 2 on this one because it says or equal to. So I'm putting in -1 and I get -1 squared, which is 1. And then I put in 0, and that is 0. And then I'm going to put in 1, and that is 1 squared, which is 1. And then I'm going to put in 2, and that's 2 squared, which is 4. I'm going to graph all those points. -1, 1. 0, 0, 1, 1, 2, 4. Oh, it's part of a parabola. That makes sense. Because look, it's x squared. And then last but not least, the absolute value. Well, I know it kind of looks like this, but I'm not going to draw it. I'm going to like not only start drawing it right there. But if I want some actual points, I'm going to put in things like 2. And then I'll just put an empty circle because it can't be 2. But I put in a 2 into this function, and its absolute value of 2, which is 2. So 2 comma 2. Empty circle right at 2, 2. And then if I put in a 3, I'll get 3. And if I put in a 4, I'll get 4. And I think I get the idea. And it just dots that go up like this. Yay, I'm doing it right. There is my piecewise function. Okay, next part. Use the same exact function and tell me what you get when you put in x equals -5. If you ask me which function to put it in, then you don't understand. If x is -5, what's the answer? Y is what? Don't say it. Figure it out. So some kids that think, well, there's 3 answers. It depends. It depends on if you use the top function or the middle function or the bottom function. Mr. Martin, why is that not an accurate statement that there's 3 answers? All right. Sylvia, do you know why there's only going to be one answer for this?
No.
Okay. I'm gonna help you focus on this way. X is negative 5. Will this function work if x is negative 5? Yes. Will this function work if x is negative 5? No, because it's not in the zone. Okay, so will this function work if x is negative 5? No, because it says x has to be bigger than 2, so it wouldn't work in the bottom two. It has to be the top one. And if I'm taking the top one, it was x minus 4. This is an old leftover negative 2 up there. So if I stick in a negative 5 was what we wanted? Yeah, negative 5 goes in the function. I got negative 5 minus 4 is negative 9. Who had a negative 9 sitting there waiting for everybody else? Okay, good. Now I'd like you to try. Would you please put in the number 7? If x is 7, it's actually really easy, isn't it? Which of these three functions should you use? The top, the middle, or the bottom? If x is 7, yeah, x has to be bigger than 2 there. 7 isn't between negative 1 and 2. So the only one it could possibly work in is the bottom one. And so when you put in 7 down there, absolute value of 7 is 7. When you put in 7, you get 7. If you want to write it as a point, it'd be 7 common 7. Otherwise, if you just said if x is 7, y would be 7. Only works in one of the functions. Okay, that's a big, important topic. So I'm going to give you one last one. What if x is a and a is bigger than 4? Which function do you use? Throwing in that extra variable is really annoying, Mr. Server. I know, and it's on your homework, so I want you to understand what they're doing. If x is a, but a is bigger than 4. Yes, it's got to be the bottom one. Why? Well, just pick a number that is bigger than 4. Let's say a was 5. Would you agree that a is 5 works in that? Well, then you could say it's like 5. And if x is 5, then you'd have to use this function. All right, I'm going to do it in that weird way again. I'm going to do one more. What if I said x is equal to a and a is between 1 or negative 1 and 1? Which function would you have to use? Top, middle, or bottom?
Middle.
Middle one. Because if you're between negative 1 and 1, you'd fall in this range right here. And so therefore you'd have to use the x squared function. Okay, good enough on that. Yes, question?
So when you're using an extra variable, once you figure out what function you're going to use, what do you do from there?
So I'll show you. We got another homework problem that's kind of like that. So let's do one like that, because we'll address that right now while I just talked about it. So what if I just said y equals x squared? That's pretty easy. Can everybody graph that? Just graph y equals x squared. Should take you like half a second. What if I said to graph y equals x squared plus a? All of a sudden that seems like, oh my gosh, that's impossible. What if I told you what a was? Then it'd be pretty easy, wouldn't it? So it would be easy if I just said, well, a is 3. Well, then you know, oh, well, then you just asked me to graph x squared plus 3. So I'm just going to move it up 3. That'll be easy, right? But what if instead I gave you a range of numbers for a? Let's say I said a was bigger than 3. Well, to start with, just figure out where x squared would be. Okay, just plain old x squared. Did you know that it was going to be like this? That's x squared. But then I have to add something. Which way is that going to move it, up or down? Up. Unless a was negative, that'd be kind of a tricky twist to that. But let's say a is just a normal, natural number, okay? And so it's going to move this whole thing up. So you just, if it says A is greater than 3, my advice to you is graph 3, 4, 5, and 6. Just graph a few of them. If I said A is 3, do you get this whole thing would be moved up? But remember, it says bigger than 3, so I'm going to go to where 3 is. And then I'm going to make a dotted line there because it's still a parabola, but it can't quite be there. And then if I made it 4, it would actually exist, and then it would be moved up 4. And if I made it 5, it would be up further and further. Do you get it's like shading above the dotted line? That's how you graph that. It's a parabola. It's dotted because it can't be 3. It says it's bigger than 3. So right at 3 there, it had to be dotted. So this dotted line right here was where you'd start, but then it's parabolas that are bigger than that. So you could just shade above it. I'd be okay with drawing lines like I did, or with like shading like that. I want to warn you, your key does not explain this well, and it doesn't graph them well. I think the teacher that was doing it was doing their best, but the key for today's, like, the problem set from yesterday that I told you was not homework, you didn't have to do it, you just worked on it in class. We're going to work on them again in their work time today, but they don't do these well. So I'm going to do one more like that. You guys know what y is x squared, absolute value of x looks like? You need to know these like the back of your hand. You got to be like, oh yeah, that's a V shape, easy. So graph the V shape. But then I'm going to say it's plus A. Well, it's the same as last time, except this time I'm going to say that, what do we know about A? Oh, A is less than or equal to -2. You should be able to graph a whole family or shade it and see what this graph looks like. Okay, so you start with the V, and then since it says -2, I would just start with -2. If I had just said graph absolute value of x minus 2, you'd have just moved the V down a couple, wouldn't you? And then do I keep going down, or do I go up from there? Well, try another number that works. It has to be less than -2. What's a number that's less than -2? -3. And then I graph it and I go, oh, I guess I'm going down. -4. I guess I'm going down 4 now. See what I'm doing? I can just kind of follow the pattern now and just go like that. If you wanted to shade underneath instead, I've been fine with that. So that's weird, but yeah, you're going to have to know how to do that too. There's some in the homework like that. And again, I don't think they do them well. They just shaded over the top one like this, and somehow you were supposed to know that that meant that it shades underneath it forever. So that's, anyway. Don't be too confused on the key there. Okay, last thing. Implied domain. If I said, hey, we're having a party on Friday, I'm implying I'm inviting you. This is saying, hey, x squared over x minus 7 is a function. And you should know that x can't be 7. You should know that. It's implied. X cannot be 7. But that's not the domain. Would you please tell me the domain? The domain is what you can safely feed this function. Try this one and compare it with the kid that's sitting next to you. Give it a second. Compare your answer to the kid next to you. All right, see what you think. I'd put it on a number line personally. Do you guys compare already? Did you compare already? All right. Can you just do one last thing? Right over that darker, because I can not read it. It's too thin. All right. Cooper, what'd you say?
I said negative infinity 7 in parentheses, union 7 infinity in parentheses.
Union 7 to infinity. Raise your hand if you agreed with him. Good. All right. Now, last one, I promise. Square root of 2x minus 3 over x squared minus 4x minus, no, plus 3. There we go. Sorry, it took a little bit to give birth to that one. Minus 4x plus 3. There. Find the implied domain of that one, and it is nasty. But we test on this level of nastiness. So, I'll pause for a second, give that a try, and then we will have a bunch of work time, during which I hope you will be smart enough to do some problems in class, because you don't have to do anything at home tonight. And then if you're stuck, bring it up and ask me. Just all I ask is that you look at the key first, because there's only one of me and there's 30 of you. So if you all have a question, there's no way. So look at the key first. If I were doing this, I would have grabbed this 2x minus 3 and already brought it over and said greater or equal to 0. Who knew that already? Good. If you didn't know that, that's critical. And then I would pull out my favorite saying, which is if you can factor it, you should. And this would have factored if you do it right. And then that would tell you a couple more things about your domain. Now pause for a minute. You work on that. I know you guys are still working on it, but I'm going to start the process of solving. You all know I was going to add 3 there. 2x greater than or equal to 3. X greater than or equal to 3 halves. That's the same as 1 1/2. I'll put that on the graph right now. Here's 3 halves, aka 1 1/2. And it's bigger than or equal to that. Then this one factors to x minus 3 and x minus 1. How many of you caught that? Good. So there's 2 things that it can't be. It can't be 1 and it can't be 3. Notice those are can't be's. Okay, 1 is back here. Can't be 1. That really isn't going to change my answer. But it can't be 3. 3 is bigger than 1 1/2. That's like over here. Can't be 3. That does change my answer. And then a lot of people get confused on what about the numbers bigger than 3? Do they work? Well, try it. You try a number like 4 and you see, does it work? You put it in and you really are asking, does it crash my function? And that's got a square root over some decimal. And as long as that decimal isn't 0, which it isn't, then it works. So yeah, your answer is between 1 1/2 and 3, and from 3 to infinity. Any questions? Yes.
So for this one, I just did the bottom, and I just saw that, and I just did the negative infinity 1, 1, 3, 3
Yep.
infinity.
Yep.
If I do that, but I don't prove that the top can't equal a negative,
But you might have thought that your answer was from, if your key numbers from the top, or sorry, the bottom, were 3 and the 1, right? That's this and this.
yeah.
Then you would have also allowed things like 1.1, 1.2, and it's really only starts working at 1.5. So yeah, if you didn't have that top part, if you didn't have the 1 1/2 somewhere on the graph, you couldn't have it right, because it only starts working at 1 1/2. So your final answer is 1.5 to 3, bracket on the 1.5, and then 3 to infinity. And I think if you had only done the bottom, you would have thought it was from 1 to 3. So it's picky, but math is picky. Top and the bottom need to be considered. All right, and that's all I got for you for the video for today.